Now this video looks at motion under a variable force and acceleration. Now there are actually 4 different sections to this, so I'm going to record 4 different videos and then you can complete questions on each that relate to each type of example, or you can watch all 4 videos and then complete all the exercises at once. Okay, so that's up to you. So firstly, we're going to consider situations where the velocity or acceleration of the body, for example, is a function of position as opposed to time. Okay, so first, the example we're looking at here, a particle moves in a straight line such that its velocity v centimeters per second is v of x equals 1 over x plus 2 centimeters per second, where x is greater than negative 2, and when t is 0, x is 0. So there are our initial conditions. So part A, determine the position x as a function of time t. So our velocity is equal to 1 over x plus 2, where x is greater than negative 2, which it has to be because if x was, well, it can't be negative 2, because if x was negative 2, we'd have an undefined function. Now velocity is dx dt, so dx dt is 1 over x plus 2. Now because we've got x's on the right, we need our dx on the bottom, so we're going to invert. So dt dx is x plus 2. So that means our t is going to be the integral of x plus 2 dx. Now, if you're not, just to give you a bit of background on here, if we did the intermediate steps, we've got dt dx equals x plus 2, which means dt is x plus 2 dx. We then can integrate both sides, and the integral of dt is t. Okay, we just don't write all those steps, just a bit of background there. Might help later on with some of the other questions. So anyway, the integral of x plus 2 is x squared over 2 plus 2x plus c. Now we use our initial conditions. When x is 0, t is 0. So if you plug x is 0 in there, you get c is going to be 0. So that means that t is x squared over 2 plus 2x. Now we want the position x as a function of time. At the moment we have time as a function of x. So we need to make x a subject. So multiply everything by 2. So you get 2t equals x squared plus 4x. Now the only way we're going to be able to isolate x is if we complete the square. So if we complete the square, we get 2t equals x plus 2 all squared minus 4. Okay, so that means our x plus 2 all squared has to be equal to t plus 4. Okay, so x plus 2 has to equal plus or minus the square root of 2t plus 4. Now we don't have to look at the negative version because x is greater than negative 2. So that means x is going to be equal to my negative 2 plus the square root of 2t plus 4. Okay? Now position after 2.5 seconds, so t equals 2.5. So x was negative 2 plus the square root of 2t plus 4, which is going to be negative 2 plus the square root of 2 times 2.5 plus 4, which is negative 2 plus the square root of 9, negative 2 plus 3, which is 1. Okay, and our units were centimeters per second, so that's centimeters. So therefore, after 2.5 seconds, the object is 1 centimeter to the right of O. Now looking at the distance travelled in the first 2.5 seconds, now v was equal to 1 over x plus 2, and x was always greater than negative 2. So that means our velocity is always going to be greater than 0. Okay, so v is greater than 0 at all times, which means our object is travelling to the right. So that means our distances are always going to be positive as well, because we are finding distance. We're finding distance, not displacement. So those positives and negatives matter. We know that it's always positive. So our distance is going to be equal to whatever we get for our position at 2.5 minus whatever it is at 0. Okay, at 2.5 it was 1, and at 0 it's going to be -2 plus the square root of 0 plus 4, which is 1 minus -2 plus the square root of 4, which is 1 minus -2 plus 2 is 0, so it's just 1. Okay, so therefore object travels 1 centimetre. In first 2.5 seconds. So you can go and complete MathsQuest exercise 12.12C, page 571, questions 1 to 3, or you can move on to the